Namaskaram everyone. Today we are going to discuss with a beta function. Let us know what is a beta function. So let us start with the definition. Here, if m is greater than 0 and n is greater than 0, then definite integral. Definite integral is nothing but the integral with the limits which exist with the limits is called definite integral. Integration of 0 to 1 x raised to m minus 1 into 1 minus x raised to m minus 1 dx called a beta function, and it is denoted by this is beta of m comma n. This is the denotation of the beta function. So formula is beta of m comma n is equals to integration of 0 to 1 x raised to m minus 1 into 1 minus x whole raised to n minus 1 dx. Here value of m and value of n should be greater than 0, means it should be positive. If the value of m and n are negative, then this beta function does not exist. So here next let us look at some examples. First one, that is beta of 4,6. This equation, how this equation can be written in this form. Let beta of 4,6 is equals to where 4 is m and 6 is n. So put the values of m and n in this equation. We'll get 0 to 1 x raised to m is nothing but 4 minus 1 and 1 minus x raised to whole raised to n is nothing but 6 minus 1 dx. So next this is equals to 0 to 1 integration from 0 to 1 x raised to 4 minus 1 is 3 and 1 minus x is whole raised to 5 dx. This is the equation we got. So similarly you try this equation beta of 3 comma 2 and 1 comma 2, and this is for homework. Let me know in the comment box. Next, so let me share about this, that is write the beta function 0 to 1 x raised to minus 3 into 1 minus x raised to 5 dx. What is the beta function of this? We know that this minus 3 is nothing but m minus 1 is equals to minus 3, and this is 5 is nothing but n minus 1 is equals to 5. So when we get to know the value of m and n, we can substitute in beta of m comma n. So let us find the m value here. Here m value is equals to minus 2 and n value is 4. So beta of minus 2 comma 4. Here this function is not a beta function. Why? Because here m is we know that in the formula the m should be greater than 0 and n should be greater than 0. Here m is less than 0, so this is not a beta function. So this is not a beta function. Now let us know some properties of a beta function, that is properties of beta function. First one is beta of 1 comma 1 is equals to 1. Let us prove this, that beta of 1 comma 1 is equals to 1. We know the formula, right? According to the beta function definition, beta of m comma n is equals to integration of 0 to 1 x raised to m minus 1 1 minus x raised to whole n minus 1 dx, where n is greater than 0 and n is greater than 0. This you have to mention in your definition to get the full marks. So now by comparing the above equation, we know that m is equals to given m is equals to n and n is equals to n. When we put in this equation, we will get beta of 1 comma 1 is equals to integration of 0 to 1 x raised to 1 minus 1 is nothing but 0 and 1 minus x raised to n is 1 minus 1 is 0 dx. Integration of 1 x raised to 0, something raised to 0 is 1, and 1 minus x raised to 0 is also 1. Something raised to 0 is 1, always 1. So this is also 1 and this is also 1 dx. We know that the integration of a constant function is nothing but that respective function. Therefore x to the limit 0 to 1, this is equals to 1. Hence proved beta of 1 comma 1 is equals to 1. Now let us deal with the second property, that is beta of m comma n is equals to beta of n comma m. This property is also called a symmetric property, because here these are the inverse, mirror inverse, so they are called as a symmetry. So we know that the formula of a beta function is this, and where you have to, in this formula, in this equation 1, put x is equals to 1 minus x. So you'll get beta of m comma n is equals to integration of 0 to 1 minus x whole raised to m minus 1, because put x is equals to 1 here, 1 minus 1 minus x whole raised to n minus 1 dx. Now solve, simplifying this to m minus 1, and here this minus 1 plus 1 and minus 1 will get cancelled, and minus will be x raised to n minus 1 dx. So if you compare this, so let me rearrange this of 0 to 1, x raised to n minus 1 and 1 minus x raised to m minus 1. So you compare this formula and this. See here x raised to m minus 1, so we had written m first, 1 minus x raised to n minus 1, so we had written second n here. So you, by saying this, here x raised to n minus 1, n is first, so we'll write beta of n, and 1 minus x is second, whose power is m minus 1, so we'll write second m. Beta of m comma n is equals to beta of n comma n. This is the second property of the beta function. And at last there is a note that it tells that if m and n are positive integer, then let me underline this word positive integer, where m and n are positive integer. They should be positive and they should be integer. Then beta of m comma n is given by m minus 1 factorial into n minus 1 factorial divided by m plus n minus 1 whole factorial. Here see, m should be positive, it should not be in the fraction form, and it should not be at all in the negative. It should be positive and integer. This you should underline and keep this in the mind. Then only you should work out with this formula. And guys, this is all about the beta function. Let me do some problems regarding beta function, and that will be not this long video. I will be uploading it in the form of a shorts, so that it can be easily referred to you, and it is time saving to you. Thank you.